thank you all for joining our Hitchhikers exclusive webinar, Tackling Search Data with AI. I'm really excited about this webinar. We've got a great list of presenters here, which I'll introduce in a moment. We're also talking about a topic that I think is going to be extremely valuable for pretty much everyone on this call, and that's how you can use Yext AI technology, Yext analytics, to actually tackle your search data, to make actionable insights, to make actionable changes. This is part of an ongoing series that we put together where we're taking a number of key features that are new to the product, key features that we think can add value. We're going to talk today about our search term clustering. So I wanted to introduce our speakers here. We've got three awesome speakers. The first is Ariana Martino. She is on our platform product marketing team, specifically focusing on the Answers product, as well as the analytics product. And then we've got Mike Peralta, our product manager for analytics, and Max Davish, one of our Answers product managers. So each of them is going to take you through a couple key components that are going to add up to a big picture to help you open up the picture for what your search data is showing. As far as an agenda, Ariana is going to open it up with the value of search term data. We understand that everyone is getting a lot of searches. What can you actually do with that data? How can you actually analyze it? And then we've got two great demos coming up. The first from Mike, he's going to show you how to actually use the feature, how to use search term clustering, how to quickly get value from it. Third, we are going to have a demo from Max, where he's going to show us the actual AI behind it. What is the actual data model that we're using? How does it work? How do we find these clusters? And then finally, we'll close it off with what's coming next from Hitchhikers, and we'll have a live Q&A with the presenters. So with that, I will turn it over to Ariana.
Thanks so much, Nick. Hi, everyone. My name is Ariana. As Nick mentioned, I'm a member of our platform product marketing team here at Yext, here to talk a little bit about why you might be interested in getting more information about what your customers are searching for in the form of your search term data. Now, to understand search term data, what we mean by that, we're envisioning a situation where a customer has a question about your brand, they want a little bit more information, and they decide to get that information by conducting a search potentially on your web page. So say in the example customer journey, customers interested in maybe visiting one of your physical locations, but they don't know what location is nearest to them. So they hop onto your website and they decide to search for locations near me. Now, in the best case scenario, they're faced with a lot of structured, valuable information about the locations that are nearest to them that might have the services and products that they're looking for, and a lot of really convenient calls to action that are bringing them towards that next step of converting and getting a little bit more information that will actually lead them to becoming a customer. And that's when the customer engages with your brand. Now, if you're using Yext for your search experience, we're able to aggregate all of that information in the form of your search analytics. And that's going to be able to show you not only what the customer searched for at the beginning of their customer journey, but also the steps they took afterwards. Did they view any pages? Did they click on a call to action? Maybe they got directions that would bring them to the location that they're interested in visiting. And that analytics is valuable in a couple of different ways. Now, the first way is that, of course, building customer intelligence has a lot of value in and of itself, because it's always really important to understand what your customers are searching for. That customer intent shows you, what do customers want to learn about your brand? What are they hoping to get from the information that you have online? And what would they ultimately like to be able to convert on? And second, and this is equally important, is being able to get a comprehensive view of your search term data allows you to actually make improvements to your search experience that close content gaps. Let's say alternatively, this customer was looking for something a little bit more specific, like they were searching on a bank's page. They want to know how they're able to cash a check. If they were faced with pretty much no results, nothing that answers their question or nothing relevant, they're unlikely to engage with you. They're unlikely to convert, and they might not come to your search experience again because of that negative customer experience. So being able to identify those content gaps is really critical to constantly be optimizing and then provide a better customer experience next time, because that positive customer experience is going to be what drives people to come back and search a second time. Now, taking a little bit of a step back about search term data more generally, it's clear that data about what people are searching for provides a lot of rich insights to really get at that customer intent. But trends overall potentially can be hard to spot amongst thousands of searches. Often we're getting a very large volume of searches, and it can be hard or even impossible to manually sort through it all. There's also a pretty uniquely human element to search term data in that two customers who have the same intent might come to the same search experience and write fairly different queries based on how it's phrased or how it's formatted. They might be thinking about it in a slightly different way. And so it's easy to lose the forest and the trees and not be able to get to the root of what the common trends in customer intent are. In the example here, it's clear through the various different searches highlighted that customers have a lot of questions about how they might be able to check their gift card balance. But if those intents are spread across a bunch of different searches and hidden amongst unrelated searches that are equally popular, like searches for your locations or for your menu items, it might not be immediately clear that this is a trending topic that people really care about, and you want to make sure you have a strong answer for it. Why would you care about having a strong answer? This is an excellent question. And that's because there is a pretty high cost to leaving questions unanswered in your search experience. And that's for two reasons. The first is that generally search is really valuable to customers. 84% of people would prefer to transact using some type of search. They wouldn't want to get their questions answered through something that's more cumbersome for them and more cumbersome for you, like calling a helpline or submitting a question online or searching through lots of different pages. On the flip side, a negative search experience does have a pretty high cost. 68% of people who have a bad experience on search are not going to return. So when customers have that high value, they're really interested in your brand, they're taking the time to search, we want to use that as an opportunity to push people towards conversion as opposed to pushing people away from your site. And that's why at Yext, we have our Answers product that utilizes AI search, and that we launched this new analytics feature, search term clustering, so that you can get a comprehensive view of customer intents that utilizes AI to get to the root of what customers are searching for, even if they're phrasing it slightly different ways. That is why I will pass it over to Mike, one of our wonderful product managers here at Yext, to show you a little bit more about how to use this feature.
Great. So I'm going to walk you guys through a typical kind of medical answers experience, run a couple searches, and show you how different searches can return similar results and how we work to combine those in analytics to make it easier for you to understand how to improve your experience and then also understand what people are asking for. So this search has a couple of different verticals. It has an FAQs vertical for coronavirus specifically. We have an events vertical, a general FAQ vertical, jobs, locations, providers, specialties, and then we have universal search. So there's a lot of different things that you can search on this experience and a lot of different questions that can get answered for your customers. So I'm going to run a couple searches that will return similar answers. First one is career opportunities. So as you can see here, we return FAQs about career opportunities and also a bunch of job listings that we have. Similarly, someone could come in and want to search jobs. And as you can see, we return the exact same set of results because we understand that these have the same meaning and therefore should have the same answer to them. And then finally, as another example, I can show you if you run careers, same thing. You'll get the FAQ about what career opportunities we have. But besides that, you can also run something very specific, like, what dermatologist in New York takes Cigna and speaks Spanish, right? So this same experience can handle a bunch of different questions. And it's important to understand which questions are related to each other and which are not, so that you can figure out areas of kind of importance for your customers and then also where you can start to optimize your experience. So typically the way you do this is you go to a screen like this, which is called our search term screen. And what it does is it consolidates every individual search someone ran, so like career opportunities, careers, things like that, into a single row, and then shows you the amount of times that they were searched. And this is a good way to get started, but it's not great when you're trying to scale optimizing your experience. As you can see here, in the last 30 days, over 572 searches have been run. So it'd be pretty cumbersome to actually go through this entire list and figure out what are people asking, especially when we know that a lot of these search terms, like I was showing before, are returning the same results. And so that's why we came up with this feature called search term clusters. So what search term clusters does is it uses AI to automatically group together searches that we know have the same meaning. That way you can start to see the topics that people are talking about instead of just the individual questions, so that you can start to analyze at a higher level, where are the areas that we need to improve? What do our customers care about? And how can we help them get the answers that they want? So as an example, I can show you this career opportunities one, which will group together all of those searches I was running before. So as you can see here, The cluster itself is called career opportunities, and that's because it's the most popularly searched thing inside the cluster. But there's also careers, job opportunities, jobs, and employment opportunities. These are all different ways of phrasing the same intent, which is I want to figure out if I can work for you, if you have any opportunities for me to work at your company. Similarly, we have this concept of performance. So what performance does is it uses the size of your cluster and also the click-through rate or engagement that your cluster is getting to understand, are we doing well at answering these questions? And is this a question that people are asking a lot? So as you can see here, this one is called performing well large cluster. And what that means is that it has a click-through rate of over 30%, as you can see here, as 50%, and is also representing more than 10% of your searches. So that means that this cluster represents more than 10% of the searches that people are asking, in this case, 16%, which means it's an important topic for you to handle. So luckily in this case, we're doing well. We're getting a lot of engagement and a lot of people are searching it. You can also quickly see by filtering at the top or any of these filter bars here, what are the clusters that aren't doing so well? What are the things that people are asking a lot of questions about, but just aren't getting the answer that they want? And that could be because there's not the knowledge in the knowledge graph. It could be because we don't understand their question, or it could be potentially because it's something long tail. But we want to understand where those areas we're not doing well and segment those by the size of them so that we are making sure that we're tackling the most impactful things. So as you can see here, one of these is COVID vaccine appointment. And inside of it, there's a bunch of different ways to ask about how can I schedule my appointment for the COVID vaccine. So let's say I take this search and I run it on that experience. So as you can see here, it's clear why they're not getting a lot of engagement. Most of the FAQs you provide are about COVID safety, about what the COVID vaccine is, how many doses you take, kind of more general things about it, but not a tactical, how do I actually get the COVID vaccine? How do I get an appointment for it? Which is what your customers are looking for. So the answer here is pretty simple. We can add something to the knowledge graph that answers this question. So customers know how do they schedule their appointments? And whenever they ask a question here, that'll pop up. So to do that, I can go to the knowledge graph and I can click here to add data. I'll be wanting to add a single entity. So I'll just click add an entity. In this case, it'll be an FAQ. So click FAQ here. And then this modal pops up with asking for the question that I want to give, and then also the answer to that question. So in this case, the question will be, how do I book a COVID vaccine appointment? And the answer is to please utilize our appointment scheduler to book your COVID appointment. So now all I have to do is add this entity to knowledge graph. It'll automatically get picked up by answers. And now whenever someone searches for something like COVID vaccine appointment, they'll get the answer that they're looking for. So as you can see, clustering is a great way of grouping together a lot of different terms that people are asking into common themes so that you can start attacking those at a higher level and focus on improving your experience as efficiently as possible. Now I'm going to pass it off to Max Davish to go through how this works from a backend perspective.
Awesome. Thanks, Mike. So I bet you're wondering, how does this all actually work under the hood? And the big challenge here is, as Ariana alluded to earlier, to a human being, it's pretty clear whether or not two queries or two pieces of text mean the same thing. But it turns out to be really, really difficult to teach a computer that same thing because there's a lot of nuance, there's a lot of semantics to the way that people run searches. And it's very, very difficult to capture that in a computer. Fortunately, we're able to use some of the same deep learning technology that powers a lot of semantic understanding and the rest of answers to do this task for analytics as well. So here's the way it works. The first step is to represent queries or pieces of text as points in space. Now, what does that mean? That's sort of an abstract concept. The key thing here is that we want to basically construct a series of numbers or points on a graph, like this 2D graph that you're looking at. And in that space, we want two queries that mean something similar or have a similar topic into, we want them to be close to each other. So for example, if someone searches outage or service outage or outage near me, we all sort of recognize that those are expressing roughly the same intent and that they should be close together. If people are asking for your cable box or cable modem or Netgear cable modems or something like that, that's a slightly different topic, but again, another set of common intents there. So I'll explain in a moment how we get these queries into this vector format. But let's just take it for granted that we have some way to represent queries as numbers, numbers that might not mean anything to us as people, but that are very meaningful to computers. The second step then is to use yet another algorithm to find patterns within those numbers and to try to cluster together things with common meanings. So again, taking this example, I might have this cluster in my upper left quadrant for service outages that would encompass all the queries with a similar meaning. On my right, I might have a cluster on the topic of TVs and TV guides. On the bottom right, I have this one on cable. So we need another algorithm that's basically able to take a bunch of points on a graph and try to figure out, okay, well, how would I cluster these together? What are the themes? So I want to now jump into a live demo of how some of this works. Let's start with the first part, which is turning phrases or sentences into these vectors. And again, when I say vector, think point on a graph. The key thing here, though, is that we're actually not talking about a 2D graph like the one I just showed. We're actually talking about a very high dimensional graph, 768 dimensions to be exact. And the way that we get from a phrase to a point on the graph is by using, as is the case with so many features and answers, a neural network. And specifically, the neural network that we'll be using is something called BERT, which you guys may have heard of. That stands for bidirectional encoder representations for transformers, which is a mouthful. But what it is basically a machine learning approach to turning queries into these numbers that a computer can understand and that can be then used in downstream tasks like clustering. So I'll show you how it works. Let's start with a super simple example. Like here's one string fish, and let's do another one shrimp. So what I've done here is I've ran both of these words through BERT, through this neural network, which is trained to understand language. And what BERT spits out is these really, really long numbers that, as I said, are basically meaningless to a person. Like I don't know about you, but I cannot make heads or tails of this. But this is basically a computer's way of generating a sense or understanding of the semantic meaning of a word. And you can see that it's calculated that these are pretty close. This scale is from 0 to 1, so 70% similarity is pretty good. You can see if I replace this with an unrelated word like car, it thinks that those two phrases or concepts are much less similar. If I were to say bird, oh, I spelled it wrong, bird. That's somewhat more similar. It's like those things are both animals, but still less so. And similarly, you can ask like, where can I get the vaccine? Where to get vaccinated? It sees that those are very similar. But I actually want to point out a subtle point here, which differentiates this technology from older keyword search technology. So you'll notice that that these phrases are pretty much obviously meaning the same thing. Yet they actually contain not very many words overlapping, because vaccine and vaccinated are slightly different words. Obviously, they're variants of the same word, but it's surprisingly difficult to teach a computer that. And in one instance, I asked where can, the other one I asked where to. Like Ariana said earlier, there's just a million ways to express the same idea. And it can be really challenging to get a computer to kind of understand things that are obvious to us. But by using neural networks and machine learning, we actually are able to do this very, very well, very effectively. So this is the first part, turning phrases into vectors using neural networks. The second part is figuring out where the patterns are in that vector space. And so we use yet another machine learning algorithm, something called DB scan, to basically take all of those points in space and then find the patterns or the clusters within them. So I want to show you a demo of how this works. Here is a set of points in space. And again, this is two-dimensional space that we're looking at because we're human beings, and that's all. That's the extent of the dimensions that we can handle. But remember, there's actually 768 dimensions that matter here. But a lot of the math and visual representation still carries over to that higher dimensional space. So let's restart this. And then there's a couple parameters that I control here, like how cohesive my clusters need to be. We'll gloss over that. But I want to show you a visual, explanation of how this works. So basically, basically the algorithm is going to go from point to point in this space and try to figure out, okay, is this a cluster? And so it goes, it's going from point to point, and if the points are close enough, it says, okay, that belongs to the same cluster. So going back to that example, like imagine that this here are all the different queries that are pertaining to, let's say, outages or something. And then this might be a smaller cluster about a more nuanced topic, like maybe someone wants to know how to submit insurance claims or something. And this one over here might be the vaccination cluster of all the different queries that are about getting vaccinated. And you see the algorithm kind of finds these patterns within the data, and it tries to group things together based on their similarity in this vector space. So it's really, really cool stuff. There's a lot of very interesting math and technology that go into making this feature work. And the end result is a much more coherent picture of what your users are searching for at a high level, not just search term by search term. And I think, oh, yep, here we go.
All right. Yeah, that was awesome. Oops, sorry, go ahead, Ariana.
Yeah, we'll just pass it over to Nick about what's next.
Cool. Well, thank you so much, Ariana, Max, Mike. I think that was all extremely helpful. I just love hearing kind of the science behind our products that we've created and how they work. As far as what's next, we've got a number of things on the docket for hitchhikers. The first thing that you can do if you want to learn more about this feature, go to Hitchhikers, test out, learn your analytics badge, learn your answers badge. You can share that, showcase your expertise. I think probably pretty much everyone on this call is a hitchhiker already. If you're not, go to hitchhikers.yext.com and you can join for free. There's a lot of great content like this there. In addition, we're going to be putting out a good bit of content similar to this. It can be through events, like we've got some good workshops coming up next month. We've got office hours every other week. If you have any questions and want to get those answered, we can bring on the experts. And then we also are going to have a blog series similar to what we've been talking through on these webinars, but doing deep dives into some of our features that we think can drive a lot of value. With that, we're going to turn it over to a Q&A session. I see we've already got a couple of questions, but if you have any, definitely feel free to pop those into the chat or into the Q&A box, and we'll be able to have those questions answered for you by Ariana, Max, and Mike. My questions box is flying off the screen right now. Ariana, do you want to start by reading off any questions? The box is like not showing up on
Yeah, sure. All right, so our first question is, does search term cluster also count on IP? Do we track IP addresses more generally when it comes to search term clustering? I'll pass that one over to Mike.
I can answer that one. Yeah, we do use IP address for other things, mainly about identifying whether users are bots or external or internal traffic, but we do not use IPs for search term clustering. They're not required for this feature.
Awesome, thanks, Mike. Our next question, what percentage is good when searching for similarity in phrases? Well, this is about the semantic similarity. What would be considered similar versus dissimilar?
Sure, I guess I can take that. There's actually a parameter within that dbScan algorithm that controls how similar two things have to be in order to be in the same cluster. I don't actually know off the top of my head what number that's been set at. I would Mike, you actually might know better than I. I would guess that it's probably in the neighborhood of 70%. Because if you look at it, usually anything less than that kind of doesn't have the same meaning, but it is something that's actually baked in to the algorithm, and that's part of how it works. Like if you remember that that demo of it going from point to point, basically what it does is it tries to figure out all the points that are within that radius, and if it can't find any, then it stops making a cluster. So really interesting how that works.
Oh, great. Thank you, Max. One more question on a similar topic. Could you briefly explain how you get the vector for the whole phrase or sentence from the vectors of individual words? Is it simply by adding, or are there other things like the position in the sentence taken into account?
That is a great question. So what actually happens is that it vectorizes the entire phrase all at once. And the key insight of BERT, the neural network that we're using, is that it's something called a transformer architecture. What that basically means is that it's a neural network that simultaneously looks at all of the different words in a phrase all at once and then transforms them into a vector. So as a result of that, it's able to consider the position of all the words in the sentence and also the context of the surrounding words. And this is really important because different things mean different, or different words mean different things in different contexts. Like for example, riverbank means something different than bank branch. The word is the same, bank, but in one case, but it means two different things in those different contexts. So that's one of the key insights, and one of the reasons that this neural network is so good at doing that is that it is able to consider not only the vocabulary, but also the position and the context of the words. Really good question.
All right, great. Thank you, Max. That is all we have in the chat so far. So with that, thank you all very much, everyone, for coming to our webinar. And if there are any further questions, a great way is to post in the Hitchhikers community to let us know of your questions. We'll keep an eye on that for related topics. And with that, I think we will wrap this up. Thank you again, everyone, for coming, and have a lovely rest of your day.